Hello students, welcome to lecture series on agrochemicals and pest control. In this episode, we will be studying about pesticide formulation. When a pesticide active ingredient is manufactured, it is not in a usable form. The active ingredient may not mix well with water or may be unstable. Therefore, the active ingredient is mixed with other compounds to improve its effectiveness, safety, handling and storage. The other compounds can include solvents, mineral clays, stickers, wettable agents or other adjuvants. This mixture of active ingredient and inert ingredient is called a pesticide formulation. Formulation is done to improve safety, ease of handling, storage, ease of use, effectiveness of pesticides. Hence, in this episode, some of the most commonly used formulations are going to be seen. They are an overview of the formulation process, formulation, selection considerations, formulations, synergists and adjuvants. We shall move into the first aspect, an overview of the formulation process. The active ingredients in pesticide products come from many sources. Some such as nicotine, pyrethrum and rotenone are extracted from plants. Others have a mineral origin, while a few are derived from microbes. However, the vast majority of active ingredients are synthesized in the laboratory. These synthetic active ingredients may have been designed by an organic chemist or discovered through a screening process of chemicals generated by various industries. Regardless of other sources, pesticide active ingredients have different solubilities. Some dissolve readily in water, others only in oil. These different solubility characteristics coupled with the intended use of the pesticide in the larger measure define the types of formulations in which the active ingredient may be delivered. It is preferable from the manufacturer's perspective to use the active ingredient in the original form when possible. For example, a water-soluble active ingredient formulated as a water-soluble concentrate. When this is not feasible, it may become necessary to alter the active ingredient in order to change its solubility. This would be done obviously in a manner that did not detract from the pesticidal properties of the active ingredient. Usually, an active ingredient will be combined with appropriate inert materials prior to packaging. A brief review of some basic chemistry terminologies should prove helpful in understanding differences among the various types of formulations. Firstly, sorption. In some cases, it may be necessary or desirable to adhere a liquid active ingredient onto a solid surface. For example, a powder, dust or granule. This process is called sorption and can be accomplished by two possible mechanisms. They are adsorption and absorption. Adsorption is a chemical or physical attraction between the active ingredient and the surface of the solid. Absorption is the entry of the active ingredient into the pores of the solid. Next is solution. A solution results when a substance is dissolved in a liquid. The solute can be a solid or a liquid. The components of a true solution cannot be mechanically separated. Once mixed, a true solution does not require agitation to keep its various parts from settling. Solutions are frequently transparent. Next is suspension. A suspension is a mixture of finely divided solid particles dispersed in a liquid. The solid particles do not dissolve in the liquid and the mixture must be agitated to maintain thorough distribution. Most suspensions will have a cloudy appearance. A herbicide Spike 80W is formulated as a wettable powder. This product forms a suspension when mixed with water for the application as a spray. Label information describes the need for sufficient agitation to keep the product dispersed in the spray tank. Next is emulsion. An emulsion is a mixture that occurs when one liquid is dispersed in another liquid. Each liquid will retain its original identity and some degree of agitation generally is required to keep the emulsion from separating. Emulsions usually will have a milky appearance. The insecticide Demon EC is formulated as an emulsifiable concentrate. The active ingredient is dissolved in an oil-based solvent. When the product is mixed with water, an emulsion is formed. An emulsifying agent in the formulated product helps to prevent the emulsion from separating by surrounding the oil droplets that contain the dissolved active ingredient. Moving into the second aspect, formulation selection considerations. The importance of formulation type is generally overlooked. A well-considered decision to use the most appropriate formulation for a given application will include an analysis of the following factors. They are applicator safety. Different formulations present various degrees of hazard to the applicator. Some products are easily inhaled, while others can penetrate skin or cause injury when splashed in the eyes. Next is environmental concerns. Special precautions need to be taken with the formulations that can prone to drift in air or move off target into water. Wildlife can also be affected to varying degrees by different formulations. Birds may be attracted by granules and fishes or aquatic invertebrates can prove especially sensitive to specific pesticide formulations. Next is pest biology. The growth habits and survival strategies of a pest will often determine what formulation provides optimum contact between the active ingredient and the pest. Next is available equipment. Some pesticide formulations require specialized handling equipment. This includes application equipment, safety equipment and spill control equipment. Next is surfaces to be protected. Applicators must be aware that certain formulations can stain fabrics, discolor linoleum, dissolve plastic or burn foliage. Cost. Product prices may vary substantially based on the ingredients used and the complexity of delivering active ingredients in the specific formulations. Individuals such as commercial pest control technicians or the farm workers who may not be involved in the selection process but are responsible for the actual application also should be very aware of a type of formulation they are using. As stated, formulation type can have an impact on hazards to human health and the environment. Inattention to the type of formulation being used could mean the difference between a root line application and one that is the source of environmental contamination or worse, a serious human exposure. Moving into the third aspect, formulations. Formulations are classified as solids or liquids on the basis of their physical state in the container at the time of purchase. A formulation can contain more than one active ingredient and many have to be further diluted with an appropriate carrier prior to use. Next is solid formulations. Solid formulations can be divided into two types. They are ready to use and concentrates, which must be mixed with water to be applied as a spray. The properties of 6 solid formulations are described in this episode, like dust, granules and pellets are ready to use, and other 3 intended to be mixed with water are wettable powders, dry flowables and soluble powders. Next is dust. Pesticide formulated as dust are finely ground mixtures of active ingredient and a carrier material. Dust formulations are intended for direct application without further mixing. Dust are never used where drift is a potential problem. For this reason, herbicides are not formulated as dust. In vector control, dusts are frequently used to control fleas and other ectoparasites on pets. They are also applied to rodent burrows and bait stations to control fleas in plague control operations. Next is granules. In a granulated formulation, the active ingredient is mixed with various inert clays to form particles of various sizes. Granules used in vector control operations are usually from 20 to 80 mesh in size. Granular formulations are intended for direct application without further dilution. Granular formulations require specialized dispersal equipment and may be applied from the air or on the ground. They may be used with small hand cranked units or simply scattered by hand. Granular applications of pesticide are especially useful in treating mosquito larvae in locations where heavy vegetation would otherwise prevent the insecticide from reaching the water. Next is pellets. Pellets are very similar to granules, but their manufacture is different. The active ingredient is combined with inner materials to form slurry. This slurry is then extruded under pressure through a die and cut at desired length to produce a particle that is relatively uniform in size and shape. Pellets are typically used in spot applications. Pelleted formulations provide a high degree of safety to the applicator. They do have the potential to roll on steep slopes and thereby harm non-target vegetation or contaminate surface water. Next is wettable powders. These dispersible powders are finely ground. Dry powders consisting of active pesticide ingredients mixed with other ingredients to aid in mixing and dispersion. Wettable powders are intended for mixture with a liquid, usually water, for application by spray equipment. They are generally mixed with water to form slurry before being added to the spray tank. In the tank, they require continuous agitation. Wettable powders can be used for most pest problems and in most spray equipment. Wettable powders are harder on equipment than some other formulations and can cause rapid wear on pumps, gaskets and spray nozzles. Next is dry flowables. Dry flowables or water dispersible granules, as they are sometimes called, they manufactured in the same way as wettable powders, except that the powder is aggregated into granular particles. They are diluted with water and applied in a spray, exactly as if they were a wettable powder. Dry flowables from a suspension in the spray tank. They have basically the same advantages and disadvantages as wettable powders, with several important exceptions. During the mixing process, dry flowables pour more easily from the container, and because of their larger particle size, reduce inhalation hazard to the applicator. Next is liquid formulations. Descriptions of 4 common liquid formulations that are mixed with a carrier follows. The carrier generally will be water, but in some instances labels may permit the use of crop oil or some other light fuel oil as a carrier. Next is liquid flowables. A flowable liquid usually is mixed with water for use in sprayer. It forms a suspension in water which requires continual agitation. Next is microencapsulates. Microencapsulates consist of a solid or a liquid inert surrounded by a plastic or starch coating. The resulting capsules can be sold as dispersible granules or as a liquid formulation. Encapsulation enhances applicator safety while providing timed release of the active ingredient. Liquid forms of microencapsulates are further diluted with water and applied as sprays. They form suspensions in the spray tank and have many of the same properties as liquid flowables. Emulsifiable concentrates. These chemicals consist of concentrated oil solutions of technical grade pesticide combined with an emulsifier added to permit further mixing with water. Emulsifiers are detergent-like materials that allow the suspension of very small oil droplets in water to form an emulsion. Emulsifiable concentrates are used widely in vector control operations, with final water dilutions typically being made in spray tanks. Tank mixes are usually milky in appearance. Next is solutions. Solutions consist of water-soluble active ingredients dissolved in water for sale to the applicator for further dilution prior to field application. They will obviously form a true solution in the spray tank and require no agitation after they are thoroughly dissolved. Solutions are not abrasive to equipment and will not plug strainers and screen. There are several major herbicides with wide scale use that are formulated as solutions. They include products containing paraquat, glyphosate and 2,4-D. Next is miscellaneous liquid formulations. Most liquid formulations are designed to be mixed with a carrier before application. However, some products are sold ready to use, which is abbreviated as RTU. This type of formulation generally will have a low concentration of active ingredient. Typically, the container also serves as the application device. Low and ultra low volume, which is abbreviated as ULV, concentrates used in space spraying and fogging are frequently applied undiluted. Dermal hazards are a problem when mixing these products because of high concentration of active ingredient. Low and ultra low volume concentrated formulations utilize special equipment to deliver the product in the form of very tiny droplets. Consequently, while they provide excellent coverage, drift potential and inhalation problems during application can be quite high. Next is aerosols and fumigants. Aerosols and fumigants are frequently confused, yet they have a very different properties and uses. Aerosols really refers to a delivery system that moves the active ingredient to the target site in the form of a mist of very small particles, solids or liquid drops. The particles can be released under pressure or produced by fog or smoke generators. Fumigants deliver the active ingredient to the target site in the form of a gas. Some fumigants are solids that turn into a gas in the presence of atmospheric moisture. Others are liquids under pressure that vaporize when the pressure is released. They can be used to treat objects, structures, grain and even soil for the pest insects and other vermin. Fumigants are among the most hazardous pesticide products to use due to their inhalation danger. Synergists are chemicals that can boost the pesticidal activity of an active ingredient. The combination of a synergist with the active ingredient provides a degree of pest control greater than what could be expected from the simple additive effects from each compound. Synergists are used with a variety of pesticides including insecticides, nematicides and fungicides. Synergists typically have little if any activity against the pest when used alone. However, EPA policy is to include synergists in active ingredient statement on the product label. A common example of a synergist is piperenol butoxide. This chemical synergizes pyrethrin insecticides. It is believed to function by slowing down the insect pest's ability to metabolize pyrethrin, resulting in fewer insects recovering from exposure to the insecticide. Moving into the last aspect, adjuvants. An adjuvant is any compound that facilitates the action of pesticides or modifies characteristics of pesticide formulations or spray solutions. The terminology for pesticide additives is confusing. It is often assumed that any material that lowers the surface tension of water in the spray mixtures or increases the wettability of the spray solution on surfaces is an adjuvant. Adjuvants are used in pesticide spray solutions as wettable agents, co-solvents, penetrants, stickers, spreaders and stabilizing agents. It is obvious that the term adjuvant encompasses a wider meaning than wetting agent or surfactant. There are many adjuvants that have little, if any, effect on pesticidal activity. These type of adjuvants include anti-foam agents, buffering agents, compatibility agents and drift control or deposition aids. Adjuvants are included in pesticide formulations as part of the total product which is sold by the manufacturer or as an additive to be mixed with pesticide products in the spray tank. We shall conclude this episode. The proper selection of a formulation is the critical step in any pest control process involving pesticides. It is an important management decision that has an impact on profitability, customer satisfaction, human safety and environmental quality. An understanding of the properties of various formulations has as much significance to the applicator as it does to the supervisor. Furthermore, a concern for environmental quality reflected in a responsible application requires a familiarity with the attributes of a given formulation and the potential impact its use might have on the surroundings. Understanding the formulation allows one to maximize its benefit while reducing the risk. Thank you.